Hey everyone, in this video we're going to talk about section 6.2, which is about polar coordinates. So far in your mathematical career, all of the points or graphs or functions that you've looked at have all been in terms of Cartesian coordinates, also known as rectangular coordinates, okay? And those are your just typical xy coordinates. Within this coordinate system, a point, let's say P, in the Cartesian coordinate system, is always defined by some sort of sign distance either left or right, and then some sort of sign distance up or down. Okay, so if you have a point, it tells you how far left or right to go, how far up or down to go. Well, polar coordinate system is going to measure and define where a point is a little bit differently. Okay, so let's say that we have a point P. First, in the polar coordinate system, we are always going to measure how far away that point is from the pole, which also tends to be the origin oftentimes, okay? We also measure where that point is based off of some sort of angle measure, and that can be degrees or radians from the polar axis to where that that line leading up to that point is, okay? So polar coordinates are in terms of r and theta. Okay, so r is going to be the distance the point is from the pole. And this distance can either be positive or negative, okay? So if we're going a positive amount, well, time out. So first, one of the applications of polar coordinates oftentimes is kind of within the Navy or within measuring like where ships are, okay? So if we see that positive amount, that means that we're going towards the east, okay? And that means that we're going towards this amount. If we have a negative r, that means we're either going to the west, or I also like to think of it as we're going in the opposite direction. Okay, so for theta, well, theta is just going to be our angle of rotation. Again, it can be in degrees or radians. If we have a positive theta, that means we're going counterclockwise. And if we have a negative theta, that means we are going, we're going clockwise. So this video today is going to introduce us to how to plot polar coordinates, how we can switch between Cartesian coordinates or rectangular coordinates to polar coordinates, and then vice versa, and then also how we can turn equations that are polar in terms of polar coordinates into rectangular or vice versa. So each point in the polar coordinate system actually has several different names, since that angle of rotation could go clockwise or counterclockwise. Okay, we could go around multiple times. Basically, remember, we have, what do we call it? We have coterminal angles, okay? So we can use coterminal angles to still define that point. R can also be positive or negative, so we can also kind of think about how we can get to the same place that way. So, for example, let's say that we have P, and P is 3 pi over 3. So to graph this point, okay, I'm going to come over here. First, when I'm looking at my polar coordinate graph, it's often going to look like this. And one thing that it should resemble to us is a unit circle. So basically, we're using our unit circle to be able to plot this. I noticed that there's a bunch of circles kind of all made up from here. So these are going to be how we define like this one and this one and this one. This is how we define that radius, okay? So this is how we're going to count our distance. So if I wanted to plot this point, basically what I'm going to do is I'm going to find pi over 3 first. And so I see that my my polar grid has been defined by degree measures. Well, we want this in radians, so let's go ahead and figure out where this would be on our degrees. Okay, so I know that pi over 3, converting to degrees, I'm going to multiply by 180 over pi. That's going to give me 60. Okay, so I'm going to plot it here. So I know that's the line along that I'm going to plot, okay? And I'm going to go 3. So I'm going to go 1, 2, 3. Here's that point P. Okay. So since that's my polar coordinate, there's also different ways that we can define this. So first, I could use any sort of coterminal angle. So let's say, for instance, that I didn't measure this way. Okay, I didn't go counterclockwise. Let's say I went clockwise to get around here. Well, what could that be? Well, I know going backwards, I would have gone, let's see, 5 pi over 3. So one way that I could have defined this is 3 and then negative 5 pi over 3 since I went clockwise. Okay. The other thing that we know is that we could have also used like a negative radius. So what that means is, let's say for instance that I went, let's say I went all the way around to, let's say 4 pi over 3. Okay, so 4 pi over 3 is going to be, let's see, here. Okay, and if I went 4 pi over 3, I'd go 1, 2, 3, and I'd be right here. Well, if I wanted to end up back where that point P was, a negative radius tells me that I'm going to go around 4 pi over 3, but instead of counting this direction, a negative would mean I'm going this way. So if I plotted negative 3, 4 pi over 3, I would end up back here. Hopefully, the iPad is making things not as confusing, but we'll definitely go over all of this in class. So, in example 1, we're going to find 4 equivalent polar coordinates for 1, negative pi over 4. Okay, so I'm going to plot this in purple. Okay, so negative pi over 4, let's see. Well, here's negative pi over 4, and it wants a radius of 1. So I'm going to be right there, okay? That's my P. Going forth, let's see, 4 equivalent polar coordinates. So first, I went a negative degree, or a negative radian, so we went clockwise. Let's go ahead and go counterclockwise. So if we went counterclockwise, how far would we have gone? Well, okay, we're still going to have a radius of 1, and it looks like going around, this would have been 7 pi over 4. Okay, so there's one of them. Let's find another way. Let's say that, for instance, that we went counterclockwise again, but let's make us have a negative radius. Okay, so I'm going to have a negative 1. Well, if I had a negative 1, I would have had to be here. So how many degrees did we go? Well, or radians did we go? Well, remember, also, equivalent polar coordinates, we don't have to be in radians. I could go 135 degrees. That also works. Okay. If I wanted to define that in terms of radians, this would be P negative 1, and then let's say, this would be 3 pi over 4. And then let's do one more. Let's go, perhaps, let's have a negative radius. And let's go clockwise this time. So we're going to go over here. So how far around did we go? I believe that we went negative 5 pi over 4. And so that would get us back here, because that negative would go the other way. So we're good to go. Okay, so there are 4 different ways. Now, sometimes you're going to see questions ask you about, okay, well, what if it said all polar coordinates? Well, that just means it doesn't really matter our coterminal amount. Remember, we can go around and around and around and around as many times as we want. We can still end up in the same place. So, okay, how many times, or how many radians or degrees or whatever do we have when we go all the way around? You should be thinking to yourself something about 2 pi or 360 degrees. So we would say then add or subtract 2 pi, and we'll say k. And remember, k is an integer. Or we can say then add, let's see, oops, add or subtract 4 in degrees, okay, 360 degrees, okay. All right, so we're going to graph these polar coordinates. There's 4 of them. I want you to go ahead and pause the video and try graphing them yourself, and then unpause when you're ready, and we'll check our answers. All right, welcome back. Let's go ahead and check our answers. So I have my points labeled as A, B, C, and D, just so we can tell which one is which. Check yours with what I have so far. A couple of things that I want to point out. So for B, since we had a -1 radius, when we go to 3 pi over 4, instead of plotting my point here, I want to go in the opposite direction, which lends me to B. For C, okay, we had -45 degrees, so that tells me that we are going clockwise. okay? And then for D, we have a couple of things going on. So first we have -3 and then 17 pi over 12. So 17 pi over 12, we're not usually going in terms of pi over 12s, but I do know that since if I wanted to figure out how many degrees pi over 12 would be, for instance, I can convert that. So pi over 12 times 180 over pi, and that's going to lead me to 15. Okay, so every 15 degrees is a pi over 12. Remember, the best way to do this, I think, is to find a coterminal angle. So 17 pi over 12. I'm going to go ahead and subtract 12 pi over 12, and then we'll see where we're at. Okay, so that's going to leave me with 5 pi over 12. And then so if this is a pi over 12, I want 5 of those, so 1, 2, 3, 4, 5, and I'm recognizing that I've just made a mistake. Hopefully you caught that. What's my mistake? Well, we have a -3 radius, so I want to be going in the opposite direction, so let's go ahead and fix that. So here's 5 pi over 12, that's coterminal with 17 pi over 12. So I want to go 1, 2, 3, and be down here. Okay, hopefully we're all on the same page now. Let's go ahead and turn our page. Okay, so now that we know how to plot them, another thing that we want to know is how to basically convert between rectangular and between polar coordinates, okay? There's going to be 4 different equations that we need to know. So first is we need to know how to define x and y, okay? And so to do that, let's think all the way back when we were defining trig. What did we know about connecting trig with x and y? Well, we knew that cosine of theta was equal to x over r, okay, and that was from our unit circle. And we also know that sine of theta was equal to y over r. So if we want to define x and y in terms of r and theta, I know that x is going to be equal to r times cosine of theta, so just multiplying that r over to both sides, okay, and then y is going to be equal to multiplying the r over r times sine of theta, okay. Another way to relate these, we knew that tangent of theta was equal to y over x, so that's going to be our third equation. And then our last one is going to be the equation of a circle, okay, and our equation of our circle is x squared plus y squared equals r squared. So that's a way to relate x and y together to r without necessarily needing some sort of theta. So, in example 3, we're going to convert from polar to rectangular or vice versa. So, for A, we have the polar coordinate 3, 5 pi over 6. So here, we have our r, we have our theta, we want to eventually get an x and a y. So for this, I would say let's plug theta into our x and our y equations, and then we'll have our points. So I know that x will be equal to, 3 times cosine of 5 pi over 6, and y is equal to 3 times sine of 5 pi over 6. Okay, go ahead and get your unit circle hat on because we need to evaluate this. So maybe you still have it memorized, maybe it's been a while. So let's dust off the old thinking cap. Okay, so 5 pi over 6 is going to be over here. We're in quadrant 2, so I know that x will be negative, y will be positive. If you remember your hand trick, you can go ahead and use that. So 5 pi over 6 is going to be negative square root of 3 over 2. So I'm going to have 3 times negative square root of 3 over 2. And then y is going to be positive 1/2. So 3 times 1/2. Okay, so that means we have our x and we have our y, so I'm going to write this as a coordinate. So x is going to be equal to negative 3 square root of 3 over 2, and y will be equal to 3/2. Boom. Okay, the next one, so here we are given the point negative 1, 1, and that's in, excuse me, please, that's in rectangular form, so we're going to write it in polar form. So we need to get an r and we need to get a theta out of this. So in this case, it's probably not useful to use the x or the y here because we have 2 variables that we need. So let's go over to maybe these equations. where we have the x and the y, and there's only one other variable left over. So to get our theta, let's use tangent of theta equals y over x. So it's going to be 1 over negative 1. So we are looking at tangent of theta equals negative 1. Okay, now we need to get theta by itself, so I'm going to take inverse tangent of both sides. So that's going to give me theta equals tangent inverse of negative 1. Okay, and so now we need to think. We're basically thinking, what is our value, what's our radian that we plug in, that from our unit circle it gives us tangent equals negative 1. So again, I always like to think about the unit circle and what this looks like. So remember, tangent is sine over cosine, so this means that both of those values need to be the same. I know that they are the same at pi over 4, and so we want that to be negative 1. So we want to figure out which one it is. So tangent's going to be negative, where x and y are different signs. So we are either negative here or we're negative here. Okay, so that means that we are either 3 pi over 4 or we are 7 pi over 4. Now I know what you're thinking. You're probably like, there's 2 of them. Which one? Do we have 2 polar coordinates? Well, we have to think about where was our original point. So where was negative 1, positive 1? Well, negative 1, positive 1 is here, where x is negative, y is positive. So that value of theta that we're looking for is 3 pi over 4. Okay, so we have that. The next thing that we need for our polar coordinate is we need r. I think that we're going to use that x squared plus y squared equals r squared. So I know that negative 1 squared plus 1 squared equals r squared. So 1 plus 1 equals r squared. That's 2 equals r squared. Taking the square root of both sides, we get the square root, well, plus or minus r. And so here, we need to make a decision. Okay, which one do we want? Do we want positive or do we want negative? I'm thinking that we want positive because we're going in that direction. So I'm going to have the square root of 2 and then 3 pi over 4. Okay. The next 2 are similar questions. I'm going to have you go ahead and try these on your own and then come to class and we will check our answers with these 2 questions. Alright, the rest of our video that we're looking at today, we are going to talk about changing polar mode to rectangular mode and then figuring out what the graphs of these look like. So, as a disclaimer, we are in the next section going to learn about different polar graphs, okay? With these equations that we're looking at today, these are going to be easily identifiable functions or graphs or relations that we already know. Okay, so our goal is basically to figure out, okay, well, what are these graphs? So here we go. First, we are looking at r equals 4 cosine of theta. So we need to try to get this equation to not have any r's or cosines in it. We want to try to get x's and y's. So here's what we're going to do. Okay, so I know that x comes from when we have r times cosine of theta. In this case, I have an r on one side of the equation, but my cosine's on the other. So we need to manipulate this so we can get this portion to read r times cosine of theta. So what we're going to do is let's go ahead and multiply both sides of the equation by r. Okay, so I'm going to multiply by r here, I'm going to multiply by r here. So this is going to give me r squared. And then rewriting this just in a little bit different form, I'm going to have r, or 4r cosine of theta. So this r cosine of theta is x, so that's great. So I'm going to have r squared equals 4x. Okay, so now that I'm looking at this, we have this r squared. I need to figure out a way to get rid of the r squared and introduce x's and or y's into this. So coming back up here, do we see anything about r squared? I do. R squared is equal to x squared plus y squared. So introducing this into our equation, I'm going to have x squared plus y squared equals 4x. All right, from here, let's go ahead and try to manipulate this into a form of an equation that we will know. So I'm going to go ahead and I'm going to subtract over my 4x. So I have x squared, going to group my x's together. Minus 4x plus y squared equals, let's see, I have nothing that equal. Okay, from here, it may or may not be recognizable, but our goal is going to try to be to write this as an equation of a circle, okay? And so we know that an equation of a circle is going to be x minus h squared plus y minus k squared equals r squared, okay? So to do this, we are going to have to complete the square. So we're going to complete the square for x. So I'm going to have x squared minus 4x plus something plus y squared equals 0. So how do we do this? Well, we're going to take this middle term. I'm going to divide it by 2. So it's going to be -2, and then squaring that is going to be 4. So I'm adding 4 into my equation. If I add it on one side, I have to keep this equation balanced. I'm going to add it on the other. So completing the square, I'm going to get x minus 2 squared plus y squared is equal to 4. So that's our rectangular form equation. And for this, what do we know about this circle? Well, I know that it's going to have a center. Well, hold on. We're going to say that this is a circle with a center at 2, 0. All right. Didn't write very well, so let's write this. And then we'll look at B. Okay, B says we have r equals 4 times secant of theta. So within all of this, we haven't really seen any of our other trig functions show up. You know, we saw sine, cosine, and tangent, but we haven't seen secant, we haven't seen cosecant, and we haven't sine cotangent. So I would say let's try to steer clear of any of the other ones, and if possible, let's always try to write in terms of sine, cosine, or tangent. Okay, so what do we know about secant? Well, we remember that secant of theta is really equal to 1 over cosine of theta. So I'm going to rewrite this as r equals 4 over cosine of theta. Okay, still equivalent, just rewrote it. And then from here, okay, again, we're always going to try to manipulate into one of these 4 equations. So which one can we easily manipulate to? Well, I think that this x equals r cosine of theta is going to be easiest because we could just multiply that cosine over. So that's going to give us r times cosine of theta equals 4. Well, and what is r cosine of theta? That's x. So this equation just becomes x equals 4. And what does that what does that function look like? Well, it's not a function, okay? It's going to be a vertical line with an x-intercept of 4, 0. All right, the next page is going to have a few more examples. I'm actually going to go ahead and pause this video here. We are going to finish up examples 5 and 6 in class together when I see you next. So that's all I have for this video. Remember to go ahead and try these 2 questions on your own. Be ready to check in class, and I will see you all later.